Optina transforms the diagnostic world for silent and undetected diseases with its Retinal Deep phenotyping platform. Taking advantage of the retina, the light-sensitive, highly vascularized nervous tissue of the eye to provide insights into systemic diseases. The Optina 4C camera sequentially captures, in less than a second, a series of over 90 retinal images with a field of view of over 30 degrees obtained at specific wavelengths or colors under mydriatic conditions, while the patient sees a rapid rainbow of colors. This series of images is called a hyperspectral cube of data and allows us to uncover unique and unprecedented information, as a full reflectance spectrum is available for each pixel of the image, a reflection of the tissue composition in that location. Optina has developed a proprietary method to extract thousands of features from each retinal scan, each feature using a different combination of an anatomical masks. For example, the blood vessels, spectral regions of the reflectance spectrum, and a texture measure. Texture image analysis is helpful to highlight subtle patterns in the images that are invisible to the naked eye. The technique is particularly useful to mine both the spectral and spatial dimensions of the rich datasets captured with the Optina 4C camera. A feature grid is built from each of these individual features extracted from the hyperspectral retinal dataset, each square on the grid corresponding to a specific feature. A Retinal Deep phenotyping heat map can then be developed for each disease of interest through the collection of a reference database using a recognized reference biomarker. For example, an amyloid PET scan for Alzheimer's disease or an angiogram for coronary heart disease. A sample of the general patient's population is classified according to the presence or absence of the reference biomarker. An eye scan from the reference population is used to transform the feature grid into a Retinal Deep phenotyping heat map for patient classification based on the presence or absence of a reference biomarker. A novel biomarker test development can now start. The color scale of the heat map being indicative of the discriminatory power of each feature to differentiate those with the reference biomarkers from those without. The discriminatory power increases from yellow to blue color and can be further increased through the combination of multiple features. An artificial intelligence test is built from a selection of the discriminatory features and can then be used to detect the presence or absence of the reference biomarker from the hyperspectral retinal images alone. The Optina Aware test is a precise, rapid, non-invasive digital test. Optina collects data to build Retinal Deep phenotyping heat maps for multiple underdiagnosed age-related diseases, including neurodegenerative, cardiovascular, ophthalmic, and other systemic diseases. Join us in changing the diagnostic world by contacting us if you are interested in developing biomarker development partnerships with us.